We are in section 3.4 and we're looking at a composition of functions. And a composition of functions is the only way we have to combine existing functions, two or more functions. And so let's sort of get right to it in this overview of how do we do that. So I actually grabbed an example from your quiz, so you'll have a problem something like this. And what you've got going on here is you're given two functions. So let's identify those two functions. One function is f of x is equal to x squared minus 15x. And the second function is g of x is equal to x plus 9. And in these little answer boxes, you're going to combine through addition first, f of x plus g of x, subtraction, f of x minus g of x, and C says f of x times g of x, and D is f divided by g of x. However, it also, this particular problem, it gives you the function at a point. So this is probably the most straightforward composition of functions we can have. And what I would do first is I would substitute 2 in this case it's 2, it might be something else when you hit this problem. I would substitute that in first. So if we have f of 2 in our first function, then we're going to have, every time we see an x, we're going to replace it with a 2 squared minus 15 times 2. And then let's go ahead and simplify that. And that's going to be 4 minus 30. And that's negative 26. So f of x at 2 is negative 26. I should change color for pen color too for the next one. So the next function is g of x, but we're given the point. So what's g of x at 2? That's our input. That's going to be 2 plus 9. Well, that's 11. So now we want to say, what is f plus g of 2? And you're going to be looking at negative 26 plus 11, which is exactly what that's going to be. Negative 26 plus 11 is going to give us a negative 15. So that would be your first entry. And now you don't have to resolve f of 2 or g of 2. They're just going to hold. So I'm going to put that over here. F of 2, not f of g, f of 2 is equal to negative 26. And g of 2 is equal to 11. Okay, put that in a little text box so I don't forget it. So the next piece, I'm coming over to our requirements, f minus g of 2. So f minus g of 2, probably just get a clean canvas would be helpful. So we've got f minus g of 2 is equal to negative 26 minus 11, and that's going to give us a negative 37. The next piece says take those same values and multiply them together. F times g of 2. So that's negative 26 times 11. And that's f times g of 2. And I have to check my calculator on that one. It should be negative 286. And the final one is f divided by g of 2. And you got it. That's negative 26 divided by 11. There's just nothing we can do beyond negative 26 divided by 11. All right, so that's a composition of functions at a point. one final thing I might say, if your text box doesn't accept negative 26 over 11, or it's the alternative, given whatever you are solving for f of g at a certain point, go ahead and divide that improper fraction, and you'll get some sort of irrational value, or perhaps you won't, maybe it'll be rational, but enter that as a mixed number if an improper fraction won't be accepted in the answer box. All right, enough of that. What if we're not given a specific point? A little bit more, we're left with a little bit more abstract of a function. So the first thing I just want to review with you is for any two functions, f of x and g of x, with real number outputs, we will define new functions as f plus g, f minus g, f times g, and f divided by g. And the notation is something along these lines. Quantity f plus g of x equals f of x plus g of x. F minus g of x is the same as f of x minus g of x. F times g of x is the same as your original function f of x times your g of x function. And when you're dividing f of g, f divided by g of x is the same as taking whatever f of x is and dividing it by g of x. And for this last function, granted that g of x is not 0. So, okay, that's helpful, you're thinking? Well, it will be. Let's look at how this plays out. So here is a problem that you will run into, or something similar, not only on this particular quiz, but probably on your midterm. So I wrote this problem, and I love this type of problem. So it's probably a good idea for you to watch me walk through one. So what if f of x is a perfect trinomial square, which it is. F of x is x squared minus 12x plus 36, and it can collapse into the binomial x minus 6 quantity squared. However, g of x is x minus 6. So it's cool to look at it and just recognize any patterns before you start doing the operations. So just to let you know, this is a perfect trinomial square divided by one of its binomials, or added, or subtracted, or multiplied. So we have two functions, and we're going to combine them. So the first one is we're going to take f of x, and we're going to add it with g of x. So in other words, we're going to take f plus g of x, and we're going to go ahead and say that's going to be x squared minus 12x plus 36. And now here's where we're going to add, where we will add g, plus x minus 6. So let's just combine like terms. We have a negative 12x, we have a positive 1x. So we would have x squared minus 11x, and then we have another set of like terms. We have a 36 minus a 6. That would be minus 30. You might notice that this is a quadratic that you could also equally tell me is x minus 6 times x plus 5. And I would accept either of those answers for the A part. All right, the B part, and here's where you want to be a little bit careful with your operators. So we're going to have f minus g of x. Let me bring that down here and maybe partition this off and probably change pen color. All right, so we're going to have f of x, which is x squared minus 12x plus 36 minus, be careful here, it's the whole quantity. So that means you're going to be distributing a negative 1. Negative 1 to the x, negative 1 to the negative 6. So I'm going to rewrite that right now. That's a negative 1x plus a 6. And probably in problems like this, that's where I see the most goofs. Just that distribution of the negative 1. Okay, let's see. What do we got to combine? We have a negative 12x and a negative 1x. Nothing with the x squared. So x squared minus 13x. 36 and 6 is 42. Here's why I love these problems. I would accept that as an answer. You could also factor that expression to x minus 7. I should put a plus there. And x plus 6. And again, I would accept either one of those answers. Negative 7 times 6. Oh, that won't work. This would have to be a negative 6. That'll work. Just had to think that through for a second. X squared minus 7x minus 6x is a minus 13x. Negative times negative is positive. That works. All right. That one. And now we've got f times g of x. So I'm on the c part. F times g of x. And I got to go back up. Oh my gosh, this is my long one. So f times g of x is going to be x squared minus 12x plus 36. Oh, this is going to take us a little while, but that's okay. Times x minus 6. So we got to be really careful here. So let me bring that down. Move that over. And in fact, there we go. Okay, we're going to end up with a cubic. So we have to be pretty careful with place value. So I'm going to start with that x squared. There's nothing clever we can do like FOIL. X squared times x to the first is an x cubed. X squared times a minus 6 is a minus 6x squared. Negative 12x, I'm going to take that second term by the first term, times x is a minus 12x squared. So I'm going to line up my terms vertically in terms of powers. Negative 12x times a minus 6 is a positive 72x linear. All right, now I'm going to finally take my last term in the trinomial and multiply it by the binomial. 36 times x is a plus 36x, so that's an x linear. And then 36 times a negative 6 is a minus 216. All right, so I got a couple placeholders here. Bring that x cubed down. Minus 12 and 6 is 18x squared. Plus, I'm going to have 108x to the first minus 216. So when I multiplied f times g of x, I ended up with x cubed minus 18x plus 108x minus 216. And the last one is f divided by g of x. So I'm going to take that x squared minus 12x plus 36, and I'm going to factor it. That's my f of x. So x minus 6 times x minus 6, and then if I divide that by g of x, x minus 6 binomial, leaving me with an x minus 6. All right, I'm going to close this video on composition of functions, and I will do another video on fog, which is another composition of functions. I hope that helped, or this has helped.